So hello everyone, we will be studying the characteristics of a GM tube. This is a GM tube as you can see here. Okay, so we will be studying the characteristic of this by drawing a curve. Okay, the curve is also very simple. So this is a GM counting system. This is a GM tube and this is a GM counting system. So what is the principle behind this is whenever you keep a radioactive material in the GM tube and you when the ionized when the radiations, the gamma rays from the cesium passes through the GM tube, it ionizes the gas producing electrons, which will lead to the number of electrons increasing. So what we'll do now is the initial setup will be as such. We will on the system. Okay. So now you're not supposed to go more than 700 volts as it's already written here. You have to be careful about this. Okay. So go to program, set the preset time to 30. And HV is the applied voltage. The applied voltage for if you are doing the GM characteristics, applied voltage should be always greater than 350. So we'll start it from 325. We have kept in. So what we'll do is we will this is the program and preset time will be at 30. You have to keep it at 30. If it's at 0, you can just move it up and down so that it will change. Okay. So we can do that. Now, so since this is a 30, I'm going to store it now. Okay, I'm going to store this data. Program. At last, you'll get stored data. Store without HV and everything. Done. Okay. So it will come at the initial stage. Again, when you press program, you have to come at the initial stage. So now what you do is you fix the position. You can keep it at the third or the second one. It will be much more easier. So you fix the position and during the entire experiment, this should lay at this point itself. Okay. So you take this. You will place the radioactive element here, that is cesium-137, which you are given in this experiment. So we will place it here. After placing it here, what we'll do is we have noted down the voltage. The EHT is nothing but 325 volts, as we have written it here already. So now what we'll do is we will start the stop function. We have to start it. Okay, if you start it, you will be able to get it. Once it reaches 30 seconds and at this particular voltage, this is the number count. Okay, so you have to note this number here. That is after 30 seconds. So as I mentioned already, only about 350, it will start showing readings. So at 325, this will be 0. Okay, so this is the count for 30 seconds. Okay, this is the count for 30 seconds. So it's been 30 seconds now and we can see that the count is still 0. So we can note it down as 0. And then you have to take the background count. Background count is nothing but you take the cesium material and you place it far away. And you place it in the same place. You place it in the same place itself. I've taken the second slit here and you start again. So the actual count n is nothing. The actual count n is nothing but with the cesium, and the background count is without the cesium in the same place. Okay. So once you take this, once it's been 30 seconds, we'll note down what is the background count. Yes. So once it's been 30 seconds, we can see that there is no number here. So it's 0 still. So we can take the corrected count. The corrected count is nothing but the count minus the background count. So it will be 0 minus 0, which is 0. So now we have to repeat this experiment for every 25 values. So you increase the voltage by 25 volts. You can go up to 600, not more than 700. You have to not go more than 700 as mentioned here. Okay. So we'll go till 600 and we can take such readings. Now what we'll do is we will do this mine. We will do for 375 volts. Go to program again. We will be seeing this. I'm taking it for 375. That is, I believe, values. Now store it again. Store it and we'll start. So it's 375 volts. And for this match, I have to keep both cesium. I have to keep the cesium in. Yeah, we are starting. Before starting, keep this here. And then keep it in the second place. That is 2 only. Okay. And then we'll start. So as you can see, you're getting 573 as the count. So that could be the any value. And what we will do now is you just put the cesium here, place it in the second itself, and you will start it again. So once 30 seconds has been done, we will be seeing the count value. That is nothing but the background count. So why will this count come after taking the cesium? Why the count is being, why we are able to see some value here is because when we have kept the cesium, it has already ionized the air around it. So these ionized air will be now interacting with the GM tube and showing the count value. Okay, so now we have already, now it's already been 30 seconds and we can see it's showing 14. So the previous number, that is what we have got with the cesium, minus this will give the NC value. So corrected count rate is nothing but you divided by total number of total time, that is the NC, that is this one divided by 30. So you will get a particular value. Now what we will do is we plot the graph. Now this graph is a very simple graph. You take the applied voltage across x-axis and count rate in the y-axis. So you will get a curve like this. You will get a curve like this, or steep like this. So now, as you can see, this is the plateau region. Plateau region is almost a straight line. So the starting of the plateau region will be the starting voltage, that is V1. Okay, and this is the threshold voltage. Okay, this is the threshold voltage V2. Okay, so V2 minus V1 will give the plateau length. Okay, so the plateau length VPL is nothing but V2 minus V1. As we can see from the graph, we have taken it is V2 minus V1 gives the plateau length. Now, with the beginning, that is with the starting voltage, if you extrapolate it to y-axis, it will cut the axis at N1. Okay, you take this as N1. And from the threshold voltage, if you extrapolate the graph to y-axis, it will give you N2. Okay, so N1, N2, V1 and V2, you have to know it now. Okay, so now we'll be using this formula. Operating voltage V0 is nothing but V1 plus V2, that is this plus this, that is starting voltage threshold voltage plus threshold voltage divided by 2 or into 0.5. Okay? So the average value of these will be giving you the operating voltage. And the slope of the plateau, this is very easy. So it is N2 minus N1. We have already taken that. N2 minus N1 by N1 into 100 by V1 minus V2, V2 minus V1. So this will give you the slope of the curve. And this is nothing but the GM characteristics curve. That's it.